All right, everybody. Today we are looking at section 8.4, which is angles of elevation and depression. What you need to know about angles of elevation and depression is that they originate from a horizontal line. So every time we're looking at an angle of elevation or an angle of depression, we want to find that horizontal line. An angle of depression is going to go from the horizontal line and open downwards. All right, an angle of elevation is going to go from the horizontal line and open upwards. So if we're looking at this picture, if our guy in our plane is flying along and he's looking straight ahead, he has to look down to see the people in the air traffic control tower. So that is an angle of depression. Whereas the people in the tower, if they're looking straight ahead, they have to look up to see the airplane. That is an angle of elevation. All right, what I want you guys to remember is that all horizontal lines are always parallel. All right, so that means that angles 1 and 2 are alternate interior angles, so they are congruent. So the angle that the people in the tower look up is the same angle as that the person in the plane has to look down. So your angles of elevation and depression are always congruent. All right, if you have any questions about that, go ahead and write that down now. All right, so let's take a look at identifying some angles of elevation and depression. First, we're going to start here with angle 3. Okay, angle 3 is from the hawk looking down to the bird watcher right here. So if the hawk is looking straight ahead, he has to look down to see the bird watcher. That is an angle of depression. All right, angle 4, the horizontal line comes from the bird watcher. So he has to look up to see the hawk. So his angle is an angle of elevation because, again, that angle opens up from the horizontal line. Go ahead and do angles 5 and 6 on your own. So go ahead and check your answers. Make sure that you got these correctly. Correct. Angle 5 is an angle of depression because from the horizontal it opens down. Angle 6 is an angle of elevation because from the horizontal it opens upwards. All right, so let's take a look and see how we actually use this in a problem. Okay, a lot of what we're doing today is word problems. So what we have is a lighthouse keeper is at the top of a 120-foot tall lighthouse with its base at sea level and spots a small fishing boat. The angle of depression is 5 degrees. I want to know what is the nearest horizontal distance between the base of the lighthouse and the boat. We want to round to the nearest foot. So basically what we need here, if we start breaking this problem down, is we need to draw a lighthouse and a boat. Now, I get to cheat a little bit because I have clip art. But go ahead and make sure that even if you just sketch it, which by all means a sketch is more than fine, we want to sketch a lighthouse and a boat. So go ahead, take a second to sketch that. All right, so if we look here, we know that the lighthouse keeper is at the top of the lighthouse, which is 120 feet tall. So I know that I can write 120 feet right here for the height of my lighthouse. All right, he looks down to see the small fishing boat. So from here, we're looking down to see the fishing boat. Okay, I want to know the horizontal distance between the boat and the lighthouse. So again, just like we've been looking at this entire chapter, we are creating that right triangle. Okay, I want to know how far and what the horizontal distance is between the base of the lighthouse and the boat. So this is what I'm looking for. So now the key here is, where do I put that angle of depression? Okay, so the lighthouse keeper is standing up here. So the angle of depression is going to originate from the top of the triangle. But remember that an angle of depression always starts from a horizontal line, which we don't have. So we're going to kind of sketch in a horizontal line. This right here is that 5-degree angle. All right, you guys, the most common mistake with angles of depression is that we put that 5 degrees up here inside the triangle. So one little trick you can use is that the angle is depressed because it's not allowed inside the triangle, so it's sad. All right, that's horrible, but it works, right? So remember that 5 degrees, those angles of depression, are outside your triangle. Now, remember angles of elevation and depression are congruent. So I know that this angle and this angle are congruent, so this is 5 degrees. So the biggest thing that people usually mess up here is putting that 5 degrees in the wrong spot. So anytime you have a word problem with an angle of depression, I want you to change it in your head to an angle of elevation. All right, so instead of saying from the lighthouse to the boat, it's an angle of depression of 5 degrees. I want you to think of it as the boat to the lighthouse is an angle of elevation of 5 degrees, because you put the angles of elevation in the right spot most of the time. Whereas angles of depression, if you're going to mess anything up, that's the one that you mess up. All right? But then from here, guys, that is the new part of this section. That is the only thing new today, is taking that word problem and drawing the triangle. Because from here, we're going to solve this the same way that we've been doing the last couple of sections, which is with our trig. So we're going to color in our angle, and we're going to label that the X here, the side I'm looking for, is my adjacent side. 120 is across from that 5 degree angle, so it is my opposite side, which means that the trig function I'm going to use is my tangent. So I'm going to say the tangent of my angle, so it's the tangent of 5 degrees, equals my opposite side, which is 120, over my adjacent side, which is X. All right, from here, X is in our denominator, so that means we are going to divide. So it's going to be 120 divided by the tangent of 5. And then we're going to put this in our calculator. Now, we want to round to the nearest whole number. So our answer when we round to the nearest foot is 1,372 feet. If you have any questions on that, please write them down now. So let's go ahead and take a look at another example. Okay, we have a viewer watches a hot air balloon ascend. Now, ascend means that it is going up. All right, so we have a viewer and a hot air balloon. That is what we want to sketch. Again, I get to cheat with my clip art. But this is where we're going here. All right, so we know, again, everything with this chapter is we're creating those right triangles. So we're going to create the triangle between the balloon and the viewer. Okay, so we have that the viewer's line of sight forms a 20-degree angle with the ground. So the ground means we're down here. So this is my 20-degree angle. Okay, and it says the balloon is 1,200 feet above the ground. So I'm going to put my 1,200 right here. And then I want to know how far is the viewer from where the balloon started its ascent. Well, the balloon started to rise from the ground. So this is our X. If I had said how far is the viewer from the balloon, then we would be looking at the hypotenuse. All right. So from here, again, we're going to treat this just like the triangles that we've been doing. We're going to color in our angle. All right, X is my adjacent side, 1,200 is my opposite side, so again, we're using our tangent function. So I'm going to set up the tangent of my angle, so the tangent of 20, equals my opposite side, which is 1,200, over my adjacent side, which is X, so again, my X is in the denominator, so again, we are going to divide. All right, and when we put this in the calculator, again, we're rounding to the nearest foot, so we're rounding the nearest whole number, and I should get 3,297 feet. All right, if you have questions about that, please mark that down now. All right, so let's take a look at another example. We have that Mario's eyes are 5 feet above the ground, and that they are 15 feet from the top of the flagpole. So we have Mario and a flagpole. So I had a little bit of fun with this one, and I specifically chose the name Mario because, hey, look, now we've got Mario. All right. So Mario's eyes are 5 feet from the ground. So the big key thing here is that we need to realize that this distance is my 5 feet. Okay, we are also told that Mario's eyes are 15 feet from the top of the flagpole. So since we're specifically talking about his eyes, we're going to start at his eyes and go to the top of the flagpole. Okay, I want to know how tall is the flagpole, and I want that to the nearest tenth. So this is going to be what I'm looking for my height. But my triangle is going to go here, which is going to originate from his eyes. So that means that I need to realize that this part of the flagpole here is 5 feet because we're starting the triangle 5 feet off the ground. All right, so anytime you see them say, hey, this person's eyes are here, that generally means your triangle is going to be lifted off the ground. All right, if it doesn't specifically say something about somebody's eyes being a certain height off the ground, then chances are your triangle is normal and on the ground. All right, so what I want to do is I actually want to find this side length right here to find the height of the pole, because I'm going to find this side length and then add the 5 back into it. All right, so when I look here, he looks at the top of the flagpole at an angle of 37 degrees. So this is going to be my 37 degrees right here. Okay, so now we're going to say, all right, one more piece of information that we need is that his eyes are 15 feet from the top of the flagpole. This is my 15 feet. Okay, eyes to the top is 15. All right. So we're going to color in my angle and label my sides. The 15 feet is my hypotenuse. Y is that opposite side. So now I'm going to use my sine function for this problem. So it is going to be the sine of my angle, which is 37, is equal to my opposite, which is y, over my hypotenuse, which is 15. My variable is in the numerator, so to get it by itself, we are going to multiply both sides by 15. And then we put this into the calculator. Now, we want to round to the nearest tenth. But I'm not at the end of my problem yet. So anytime you're in the middle of a problem, you always want to leave your number at least a little bit longer, so that way, you don't end up accidentally rounding something too soon. So this is going to give me 9.02 for my y. Now, to find the value of x, it is going to be y plus 5. So it's going to be 9.02 plus 5, which now, when we round to the nearest tenth, okay, this is 14.02. Well, if we're rounding to the tenths place, that means I want something in the tenths place, unless it is exactly a whole number. This is not exactly as a whole number, so we need to have that 0.0. All right, the 2 rounds the 0 down, it stays the same, so we keep the 0. All right, so please make sure that you have a 0 there when you're rounding to the nearest tenth, if it's not a whole number when you first put it in your calculator. All right, if you have any questions on that, go ahead and write them down now. So what we're going to go ahead and do now is, if you will please pause your video and do these next questions on your own. All right, so go ahead and pause your video now. All right, let's go ahead and check our answers for these first two. So when we look at the first one, we have a spectator is 500 feet from a building. That is a horizontal distance. All right. Looks up at an angle of 25 degrees to see the top of the building. How tall is the building? So we're using tangent here. All right, for number 2, we have a worker looks down from the top of a bridge that is 240 feet above the river. So my vertical distance is that 240. The angle of depression is 60 degrees. So remember, the big key here is that 60 degrees has to go outside the triangle. Switch it up so that the angle of elevation is 60 degrees. And I want to know how far is the barge from the base of the bridge. So the base of the bridge is the lowest part. So that's going to be our horizontal distance. All right. So here it's our opposite and adjacent side. So we are using tangent. Or because it is a 60-degree angle, I can also use my 30, 60, 90 relationship, where my long leg is what I'm looking, or was what I'm given with the 240 because it's opposite the 60. So my long leg is my short times the square root of 3. Divide both sides by the square root of 3. Remember, since we're rounding to the nearest whole number, I can just put this in my calculator. I do not have to simplify this. All right, if I was not rounding it to the nearest foot, then yes, we would have to rationalize this denominator. All right, if you have any questions, go ahead and write them down now. And let's go ahead and do the last one on our own. So go ahead and pause your video to go ahead and complete this problem. All right, let's go ahead and take a look at your answers here and check your work. One of the big key things here to remember is that the string of a kite is what you're holding when you're flying a kite. So that is what is connecting you to a kite. All right, so the string is 360 feet long, not the tail. All right, so you're holding the string, that's your hypotenuse. It makes a 40-degree angle with the ground. I want the altitude, which is the vertical distance, and the horizontal distance between the flyer and what's directly below the kite. So we need to do two trig functions, sine and cosine, to find each piece. Again, if you have any questions, make sure you write them down and you ask me in class. I hope you have a wonderful day, and I will see you all later.